The key to understanding asymptotes for exponential and log functions is really kind of going back to what the definition of an exponential function is. So going back to the basics. So for example, in general, an exponential function is when the variable's in the exponent and the base has to be greater than 0 and cannot be 1 in order to be exponential. And so if we just take a simple exponential function like 2 to the x, well, the domains can be anything here, but the range, if I put in huge negative values, what happens to 2 to the x? Like if I put in 2 to the negative 100,000, well, that's the same as 1 over 2 to the 100,000 rather, which is getting closer and closer to 0. So as x approaches negative infinity, 2 to the x goes towards 0. But as x approaches positive infinity, 2 to the x is going towards infinity. It's just getting bigger and bigger. So we don't call it an EBA when we talk about the asymptote in this case. Instead, we just say there's a horizontal asymptote at y equals 0. Again, because as from one side, from one end, in this case, as x is approaching negative infinity, it's approaching this number 0, but never actually hitting it. So 2 to the x is looking like that. Again, an asymptote at x equals 0, but only approaching it from one side. Well, how might that change? Well, if I just shifted this graph up 1, it makes sense, not just from a shift standpoint, that the horizontal asymptote is at y equals 1, but also as same reasoning, as x goes towards negative infinity here, the 2 to the x will go towards 0, but then you'll have 0 plus 1. In other words, getting really close to 0, but then plus 1. So when I think about exponential, I think about the exponential piece of it, so what's changing, which is going to be the piece that has the x in the exponent. And as x goes to positive or negative infinity, is that getting closer and closer to a particular value? And if so, that's going to be my horizontal asymptote, plus whatever vertical shift I have. Okay, now let's talk about logs. So with logs, instead of the restriction, and this is in general, there are exceptions, but kind of in general, unless for logs, we're not talking about a horizontal asymptote, we're talking about vertical asymptotes. And for logs, the vertical asymptotes always occur where inside the log equals 0. So for example, if I have log base 2 of x plus 1 times x minus 2, well, that's going to have two vertical asymptotes at x equals negative 1 and at x equals 2. All right, little dog freak out. So at x equals negative 1 and x equals 2. So regardless of the log, to see if it has vertical asymptotes, you set inside the log equal to 0. And if it ever equals 0, that's going to be your vertical asymptote. Because remember, what's happening there is, if I think of, actually, let's do an easier one. Log base 2 of x equals, let me see what I want to put here, equals y. So for example, so we're going to say there's a vertical asymptote at x equals 0. Well, why does that make sense? Well, remember how we find what the inverse of this function is. We would switch x and y and solve for the new y. So we'd say log base 2 of y equals x, so 2 to the x equals y. So that would be the inverse function. And in the inverse function, instead of having the vertical asymptote at x equals 0, it would have the horizontal asymptote at y equals 0. So with logs, I find it easier because you're just going to set inside the log equal to 0 to find the vertical asymptote. And with the exponential, you're just, again, kind of thinking end behavior in many respects by plugging in huge values, positive or negative, and seeing if that function is going to approach something.